We've talked about various different problems with Pythagorean theorem over the past couple days, solving for the legs, solving for the hypotenuse. What we're going to push into today are some more difficult problems. They're not more difficult because the math is any different. They're just presenting themselves in different ways, and there's one very small piece of mathematical information that we have not picked up on so far that we're going to pick on today, and we're going to look and see that right here in our first problem. Looking at our very first teacher time problem, what is unusual or different about this particular problem that we have not yet seen before? Michael. Yeah, one of our lengths has a square root. So we're going to see how we're going to deal with that today. First thing we're going to do is the same thing that we always do. We're going to label our legs and our hypotenuse. Our legs make the right angle, therefore these two guys must be our legs. And therefore are our A and B. And our hypotenuse that we don't know is our C. Hypotenuse. Again, not to be confused with a hippopotamus. Huh? All right, A squared plus B squared equals C squared. So far, nothing new, nothing different. What's going to be different is after we plug in our 7 squared is we're going to get to this square root of 32 squared. Interesting. I wonder what I'm going to do about that. Well, 7 squared is 49, and now is the questionable part. Square root of 32 squared. Junior. 32. What? I don't get it. What do you mean? How's it going to be 32? What are you talking about? Listen. Okay, somebody want to explain that a little bit differently? He's absolutely right. I want to hear some different ways of saying that particular thing, though. Javier.
He's saying that if you find the square root of 32 is going to be 16, but...
Square root of 32 is not 16, but square root of 32 is some random number.
Yeah, and then... you have to multiply that number again.
If I multiply that number back by itself, it's going to give me back to 32. Somebody else, a different way of saying it. Rebecca. Because they are what type of operations? They're inverse operations. So different ways of saying it. I'm going to say these two things are inverse operations, squaring themselves and taking the square root. Therefore, that's going to leave us with 32. So, key point. What's the square root of 56 squared? What's 56 squared and then take the square root? 56. Inverse operations. Undo each other. And if you need some more thought about how this works, remember, it's the same thing as saying like 56 plus 2 plus negative 2. There's two operations done there, but they're inverse operations, so they just cancel each other out. Same idea here with squares and square roots. We've talked about that before. We use it every time we solve one of these problems. All right, so we end up back down here. 49 plus 32 equals C squared. Gives me 81 equals C squared. This is where we use that idea that we just talked about. If I want to get the C alone, I've got to do the inverse operation of squaring it, which is taking the square root. So the square root of C squared is square root of C squared is and the square root of 81 is 9. Okay, that's the new piece. That's the thing that mathematically is new today. Everything else is really just looking at problems being presented slightly differently and having to recognize them as, hey, how do I use Pythagorean theorem for this? So let's look over to the right. It says, what is the length of the diagonal of the rectangle below? There is a definition, a key word that we must know the definition of because it is a vocabulary term that will be tested. Diagonal. What is a diagonal? Geometrically, what is a diagonal? What do you think a diagonal is? Somebody with a raised hand that I call on. Rebecca. It's like a slant. I would say that it's hard to really think about it as a slant because if I take this and I turn this and now all of a sudden what was the diagonal for is now flat, it's still the diagonal of the shape because it goes across the shape. And so that's our key thing about a diagonal, is diagonals go through the center across a shape. They are the longest distance that you can move across a shape. So pretty much you're going to always think about a diagonal as usually being from corner to corner. So our diagonal in this particular case is this line that I've now covered in blue. We're obviously talking about Pythagorean theorem, and obviously we're going to use Pythagorean theorem to solve this problem, since today we're solving Pythagorean theorem problems. But how? I don't get it. How can I use Pythagorean theorem to find the length of this slanted purple line, blue line? Javier.
Since both triangles make a rectangle, you can lift the square root to the other side.
Oh, so sorry, Javier, I got ahead of you. Javier wants to, I think what I'm hearing him say is use this triangle that I have covered up and he colored over, and he's recognizing this as a right angle. One thing that you should do anytime you see a right triangle that you plan on using Pythagorean theorem with, go ahead and do exactly what I did. Shade over the edges of the triangle that you are intending on using. The next thing that I heard him say is that if I look at this blue triangle that I have, at this point, I only know one of the three sides. In order to use Pythagorean theorem, I must know two. But he said, I know something about rectangles, and that's that opposite sides are the same. So that means that this must be the square root of 44. Most of you guys have gotten really, really good about knowing what the difference between a leg and a hypotenuse is. So I'm going to allow you to stop labeling leg, leg, hypotenuse, and I'm going to start letting you just label them A, B, C. Remember, A and B are always your legs. So our hypotenuse, our diagonal is C. Now all we got to do is plug and chug. A squared plus B squared equals C squared. I have used 12 squared plus square root of 44 squared equals C squared. 12 squared is 144. Malcolm, square root of 44 squared is? Square root of 44 squared is? Madeline? Remember, the square root of anything squared is that same number. These are inverse operations here. You said 24. You definitely said 24. We all heard it. I really appreciate what you thought you said, but it's cool. It's okay. It's fine. I'm over it. All right. 144 plus 44 is 188. Not done solving this problem. Right now I know C squared, but I need to know C. So, Maureen, what do I need to do to finish solving this? Yes, we have to take the square root.
Hey, the mark started. You better hope you don't get hit by this. You gonna watch my sports tonight too.
You have to pay for dry cleaning, man.
Yeah, you gotta take that to the dry cleaner.
You gotta pay for
I want to watch.
It's
You still ain't fixing my bike.
Looking at this next problem, it says line segment BD bisects line segment AC. There's a word in there that we may or may not know. Bisect. What does that mean, or what do we think that might mean? Rebecca. Yeah, it's the middle. So what it's saying is that this line, BD, is cutting AC in half. If you think about the word dissect, you've done that with a pig. What did you do? You cut it up. Sect comes also from the same root word as the word section, like parts. So what this does is it cuts it into two parts. Think about bicycle, BI. That prefix BI means two. So it cuts it into two equal parts. Bisect. This is a word that you must know. Cuts into two equal parts. Now, what's important there is that they're equal parts. That's what's the important part for this problem. So we'll look at that here in a second. Finishing that sentence, it says that point D is the midpoint of AC. Let's make sure that we've got that vocabulary term as well. Midpoint is exactly what it sounds. It's the middle point. So it also cuts into two equal parts. Now, the question is, why is this important for this problem? It says, what is the height of the triangle? So I can see that I am trying to find the height right here, BD. Why is it important that we know that it bisects? Let me give some of the rest of you a guiding question that maybe we'll answer it here in between. If I want to use Pythagorean theorem to help find BD, what triangle, you can use the 3 points that make the triangle, the 3 letters that make the triangle, what triangle am I going to use? Got a couple more hands. Maureen, what do you think? BDC. And so again, if you're ever using a triangle out of a larger shape to use Pythagorean theorem, I suggest that you shade over it so you can focus in on that triangle. So we want to use BDC. Now we're going to go back to the question. Why is it important that I know that D is the midpoint of AC? Javier.
Because the total length of the triangle is 30 meters.
Mm-hmm.
And the triangle is cut in half, so we have to find that half of 30.
Yeah, so we need to find half of 30. We don't need to know all the way from A to C. I only need to know from D to C. So it's really important that we know that that is cut equally in half. Okay? We only know that because it said that it was a bisector, or that it was a midpoint. Is here good? Is this good? This work? Okay. All right, so here we have two things. We have a right triangle. We have two of the pieces. I'm going to label this one as A, this one as B, and this one as C. And just a matter of plug and chug. do our exponents. Gives me a squared plus 225 equals 600. Got an extra 2 in there. A little excited, Mr. Boots. I mean, I just really like those 2's. I did it again. That's how much I like 2's. I just want to draw 2's all day long. You should see the inside of my room. Just 2's all over the wall. It's ridiculous.
It's 2 minutes.
Clever. I see what you did there. A squared equals 400. Take the square root of both sides. A is equal to 20. So we know the height of this is 20. So at this point, if I wanted to, I could find the area of this triangle by multiplying the base times the height that we just found. But it doesn't ask me to do that, so I'm not going to do that. One last problem. For all you baseball fans out there, the infield of a baseball diamond is a rotated square, as pictured below. There are 90 feet between each set of bases. If the catcher throws the ball from home plate to second base, how far is the throw? So it looks like it's showing us that dotted line is what we're trying to find out. What triangle can I use? You can use the bases to describe the points of this triangle. What triangle should I be using if I want to find
The right triangle.
that lex? Yeah, I do need a right triangle.
From home to first to second or second to third.
I heard him first say home to first to second and all the way back down. Where's our right angle? Kenneth, go ahead. First base. All right, so that means what's given to us? In terms of A, B, and C, what's given to us? Fernando, in terms of A, B, and C, what's given to us? How embarrassing. Marlon, what's given to us? A and B. And this value that we're trying to find for is C, so let's plug and chug. That's A squared plus B squared equals C squared. Is 90 squared plus 90 squared is C squared. 8100 plus 8100 equals C squared. 16,200 equals C squared. I don't need the soundtrack, thank you. That's really unfortunate that somebody just lost their citizenship dollars. Is the square root of 16,200? Now, we can estimate that this is between two numbers. That will be part of your can do. You can do that as can do. I can tell you that because it has to be larger than either of the legs, it's going to be larger than 90. It also has to be less than the sum of the two legs. So it's going to be less than 180. You can do that on your own later. All right, let's flip on over.